Dear students, in this video, we are going to see about alpha beta pruning with the example. What is alpha beta pruning? Actually, alpha beta pruning is an optimization technique of the min-max algorithm. Actually, this is the modified version of min-max algorithm. Alpha beta pruning is the modified version of min-max algorithm. It is a use of alpha beta pruning. By using alpha beta pruning, we can find optimal path from root to goal. Here we can find optimal path from root to goal state. Actually, what is pruning? Pruning is the removing of unwanted nodes or subtrees or unwanted path. So by using pruning concept, we can remove the unwanted path or unwanted nodes or subtrees. So we can save the time. We can reduce the time complexity and space complexity. In alpha beta pruning, we have two parameters, two important parameters can be used. First one is alpha, second one is beta. What is that alpha? Alpha means the best highest value. Alpha means maximum value, max. Best highest value. It is alpha. What is the value of alpha? The initial value alpha is equal to minus infinity. Beta means the best lowest value. That is the minimum value. Best lowest value is beta. Beta is equal to plus infinity. The initial value of beta is equal to plus infinity. The initial value alpha is equal to minus infinity. By using this alpha beta pruning, we can take the decision making of gameplay. So here we can find the best optimum path from initial to goal state. So mainly used for gameplay, like a tic-tac game, chess game like this. Okay. Next, we can see one small example for alpha beta pruning. Here we have a tree structure. For this tree structure, we are going to find optimum maximum value. Then second, we can find the path from root to goal node. Okay, optimum path from root to goal node. Next, we can find the pruned nodes. Here, which are the nodes are going to be pruned. So, these three things we are going to find from this tree structure with the help of alpha and beta pruning. First, we have to assign the initial value of alpha and beta. The initial value of alpha is equal to minus infinity. The initial value of beta is equal to plus infinity. We know this alpha is equal to maximum. Max means alpha. Minimum means beta. Okay, minimum is equal to beta. So max is equal to alpha. The initial value of alpha is equal to minus infinity. The initial value of beta is equal to plus infinity. Next, we have to come to each child, leftmost child. Okay. So when you come to child, whatever values in the parent, that same will repeat to child also. Okay. So the two values, alpha is equal to minus infinity, beta is equal to plus infinity. These two same values will be repeated to each child also. Okay. So what is the value of alpha? Alpha is equal to minus infinity. Beta is equal to plus infinity. Again, we have sub branch. So the same value will come to its child also, leftmost child. So alpha is equal to minus infinity. Beta is equal to plus infinity. Next, we have terminal nodes only. So we can start to do the process. First, its leftmost terminal node is 2. Okay. So here, it's a parallel. We have to do maximum. We have to check its level is given as maximum. So its level is given as maximum. So we have to find maximum value. So max means we have to update alpha. So max means we have to update alpha, update only alpha. We do not touch beta. Okay. If it is minimum, we have to update only beta. We do not touch alpha. Okay. So it is maximum. So we have to update only alpha. We do not touch beta. So what is the leftmost child of D? 2. 2 is leftmost child. So we have to check. Here we are going to update only alpha. So max of, what is the initial value alpha? Minus infinity. Minus infinity, comma, its leftmost child value is 2. Which one is maximum? 2 is maximum. So the old value of alpha replaced by new value 2. So now the new value of alpha is equal to 2. So next again we have another child also. So we have to check with that child also. Okay, next we have to check with the rightmost child. What is the new value of its rightmost child value is 3. So we have to compare with the previous value. Max of existing value of alpha is equal to 2. Now we have to compare with the rightmost child 3. What is the maximum value? 3 is maximum value. So again we can replace this old value 2 by 3. So the new value of alpha is equal to 3. The VB value not updated. So that same old value will be retained. Okay, there is no change in beta value. Next, directly we can't come to E node. Okay, so we have to go to parent. Through parent only we can come to rightmost child. Okay, so we have to go to B. It's a parent. When we go to parent, we have to update the value of alpha and beta. Depends on min or maximum. Here its parallel values minimum. It is minimum. Minimum means what I told. Minimum means update only beta. We do not touch alpha. Okay. So here we have to update beta value only. Do not touch alpha. So what is the existing value of beta plus infinitive? So what is the node value of D? Its child node is 3 only. So we have to check with its child value. So min of existing value of beta is equal to plus infinitive, comma. Its child is D, its node value is 3. So which one is minimum? 3 is minimum. So the plus infinitive replaced by 3. So the new value of B is equal to 3. Next we come to its rightmost child. Okay. So after updating the value, then we have to come to its rightmost child. Okay. Now leftmost over. So we are coming to rightmost child. So when we come to its child, whatever value in the parent, that same value will be repeated. So what is the value alpha? Alpha is equal to minus infinitive. The same two value will come to its child. Okay. So beta is equal to plus 3. Next we come to its leftmost child. Okay. Leftmost child is 5. So it's a parallel, we have to find maximum. It is a maximum. Its level is maximum. Its level, we have to find maximum value. So max of, what is existing value? Max means we have to update alpha. Max means update only alpha. Do not touch beta. Max means update alpha. So already existing value alpha is equal to minus infinitive, comma. What is the new value? 5. What is the current value? 5. So we have to check max of minus infinity 5. So here 5 is maximum. So we can replace the old value by 5. Next we have to check the condition. Once the value of alpha and beta updated, we have to check the condition if alpha greater than or is equal to beta. After updating the value of alpha and beta, we have to check the condition. Here the value alpha is equal to 5, beta is equal to 3. Alpha is equal to 5, beta is equal to 3. Condition true. True means we can prune the upcoming nodes. Upcoming nodes we can prune. Okay, its a child node can be pruned. So the node 9 removed from this, pruned. Okay, pruned means removing of unwanted, the pruning concept. So next, what is the node value? 9 is pruned, so only 5. Node value is equal to 5. Next, we have to go to B child. When we go to B, we have to update. When you come from parent to child, we do not update any value. Whatever in the parent, we have to put that same value to the child also. But when we go from child to parent, we have to update depends on min or max. So here we have to update the value for B. So it is a minimum. Okay, it is minimum. Minimum means we have to touch only alpha. Sorry, minimum means update only beta. Minimum update only beta. So here the value of E is equal to 5. So already existing value of beta is equal to 3. So we have to check min of existing value 3 What is the node value? Right child E is equal to 5. What is minimum? 3 only. So there is no change in beta value. Already existing value also minimum. So no need to change the value. No updation here. So next we from B to A. We have to go to its parent. Okay. So when you go to parent, we have to update the value. Here it is a maximum. Maximum means I have to update only alpha. Maximum means alpha update. What is the existing value alpha? Alpha is equal to minus infinity. So we have to find the maximum, max of minus infinity, comma. What is the new value? Node value is 3 only. Okay, here, isn't it? So 3. So what is maximum? 3 is maximum. So we can replace this minus infinity by 3. Next, we have to come to its rightmost child. Okay, here the value alpha is equal to 3, beta is equal to infinity. That same value will come to child also. Alpha is equal to 3, beta is equal to plus infinity. Again, we have sub-branch F. So again, we have to bring the same value to its child. Alpha is equal to 3, beta is equal to infinity. Next, terminal node, we have to check. It is a maximum. Maximum means we have to update alpha. Alpha only update. So what is the leftmost child? 0. So max of existing value alpha is equal to 3. 3 comma leftmost child is 0. What is maximum? 3 only maximum. So no updation here. There is no updation. Retain that old value. Next, it's right child. Right child, what is the value? 1. So max of 3 comma 1, again 3 only. There is no updation in alpha. What is the node value? Node depends on its children only. So node value, its max value is 1 only. So next we have to go to its root node. Its parent. Okay, we have to go to its parent node. Parent node C. So here the new value of C is equal to 1. Okay. So here we have to check whether it is maximum or minimum. It is a minimum. Minimum means we have to update beta. Don't touch alpha. Minimum means update beta. What is the existing value of beta? Infinitive. So minimum of infinitive comma a child value 1. So which one is minimum? 1 is minimum. So we can replace this infinitive by 1. Once the value of alpha and beta updated, we have to check the condition. Alpha is equal to 3, beta is equal to 1. Alpha is equal to 3 greater than or is equal to 1. Condition true. True means we can prune its sub-branch. Okay, here we can prune. No need to visit this node. These are all unwanted path. So we can remove this sub-branch G. G along with the 7 and 5 will be pruned. Okay. So next we have to come to, there is no more children. So we can go to its parent node. Parent node is A. It is a proper maximum. Maximum means we have to check alpha. What is the existing value alpha? 3. So here we have to check max of 3 comma. Its child value is 1. 3 is maximum. 3 is maximum. There is no updation in alpha. So here there is no more children to visit, so we can stop the problem. Okay. So here, what is the optimum maximum value? Here we found 3 values. We got 3 values. One is optimum maximum. Maximum is equal to, optimum maximum is equal to 3. What is the path to 3? What is the optimum path? Optimum path is equal to, from root to this 3. What is the path? A to B, B to D. A to B, B to D. This is the optimum path. A to B, B to D. Okay. Next, which are the nodes are pruned? Pruned nodes. Pruned nodes are, first we pruned 9. 9 pruned. Okay, 9. Then 7 pruned. Okay, 7 pruned. Then 5 pruned. Okay, 5 also pruned. The sub branch, with the help of sub branch G. G totally pruned. Sub branch G pruned. Okay, pruned nodes. So this is a solution. Here we got what is the optimum maximum value. Optimum maximum value 3. Optimum path is equal to A to B, B to D. Then the pruned nodes are 9, 7, 5 and G. Okay. This is the solution. Next we can see the best case of alpha beta pruning. What is the best case? When you compare to min-max algorithm. Okay, so in alpha beta pruning, here we pruned unwanted nodes. Here we not visited unwanted path. So we have saved the time in memory, isn't it? So reduce the time complexity of the min-max algorithm. So when we compare to min-max, here we use less time because unwanted nodes are pruned from here. So here given reduce time complexity of the min-max algorithm from big O notation of b power d to big O of b power d by 2. Here me means branching factor, d means depth of the tree. Dear students, in this video we saw about alpha beta pruning with a small example. And thank you students.